will do in this section is we will learn the concept and algorithm for Radix sort before we go through the demo practice in the exercise sections to get a better understanding. First, we will take the concept section. In the concept section, we need three basic concepts that we will need for the algorithm. The first is the idea of place value in a number. As we can see in this example, we have 2 as the units digit, 9 as the tens digit, 7 as the hundredth digit, and so on. This is a basic concept that everyone understands. We can now move on to the other concept that we require and which is key to the functioning of the Radix sort algorithm, the idea of buckets. Buckets is what we use in many other algorithms like counting sort, where we place an item in a bucket. In this algorithm, we'll be using these buckets based on digits. So say we have a number based on base 10, then we would be using 10 buckets, one for each digit. So what we'd be doing is, when we're doing the algorithm, say we have a number 34 and we are using a process where we have to place this item into bucket 4. Then we'd be placing this particular number into a separate segment or a data structure like a bucket. And finally, the last concept that we require is the digit extraction. You can see in this section about how to extract a digit from a number. So say we have a 5-digit number, for example, as shown here, 26483. How we would extract the hundredth digit from hundredths place from this number would be to first divide the number by 10 power 3 minus 1, that is 10 power, so to extract the ith digit, we would divide the number by 10 power I minus 1 using integer division so that we can get rid of the rest of the floating point values, and then we would use modulo 10 to extract the digit that we require. Now we will understand the Radix sort algorithm. The basic algorithm has uses the knowledge that we had got from the concept section. We'd be using the concept of buckets and place value of the numbers. Now what we do in this algorithm is we would be considering the numbers according to their digits. We'd be taking the numbers from the least significant digit to the most significant digit in the number, and we would be sorting them according to the digit under consideration in each iteration. So what we would do is we would first sort the number according to the least significant digit, then the second least significant digit, and then we go on till the most significant digit using the buckets as we see in this diagram. So first we see the elements in blue are the ones that are unsorted, and the numbers that are underlined are the numbers under consideration. Then we see that these are the digits extracted, and we'll be sorting these numbers only based on these digits given in the green boxes. Then after the first iteration, we get the second set of blue boxes, which would be then considered for the tenth digit, and the next step for the hundredth digit, and then we get the final sorted array as shown. Now when we are doing this using buckets, we would be using a situation like this. So say we have the numbers after the first pass, after we've done it with the least significant digit, now we have to consider the tens digit. As you can see, the underlined numbers are then accordingly put into buckets. So 291, 9 is the considered digit, so it goes into bucket number 9. 913 is then considered, then we have 1 is the considered digit, so it goes into bucket number 1. After we fill the buckets in a similar fashion, we then take these buckets and sort them into our output array, which would be as follows. We would be considering the buckets from left to right, and within the same bucket we would be taking the numbers out in a FIFO manner, that is first in first out. So as you can see here, 913 goes into the bucket number 1 before 315, hence 913 comes out first before 315 in the final result. We can demonstrate this using a simple example of 5 numbers. Now we have an example here where n is equal to 5 and d is equal to 2, where n is the number of elements in the array and d is the maximum number of digits in a particular number in the array. For the first iteration, we would be considering the least significant digit, that would be the ones place or the units digit. As you can see here, we will highlight first all the ones digits. Now the next step, after we identify what the ones digits are, we have to extract these digits and put them into buckets. Going through the array, first we have 54. This number would go into our bucket number 4. Then we have number 23 that goes into bucket number 3. After that we have 13 that goes also into bucket number 3. Then we have 9 that goes into bucket number 9. And finally we have 75 that goes into bucket number 5. Now, like we said, we would be going through the buckets in left to right fashion, and within each bucket we'd be taking the numbers in a first in first out manner. So first we go from 0, we have no elements in the bucket, then 1, then 2. So the first bucket that we have elements in is bucket number 3. So remembering the FIFO manner that we have to follow, first number to go into the array, the final result array would be 23, then we have 13. After that, in bucket number 4 we have 54, then 75, and finally 9. Now that we have completed the first iteration with the units digit, we move on to the next significant digit, that is the tens digit. So here if you see in the array, we have 5 from 54, 2 from 23, 1 from 13, and make note of this that we have prepended 0 to 9 because there is no significant digit after that, but since we have to consider the element, we prepend zeros as many as required to serve our purpose. So we consider 0 from 9 and 7 from 75. Putting them into the buckets, 54 goes into 5, 23 goes into 2, 13 goes into 1, 9 goes into 0, and 75 goes into 7. Once again, following our left to right and FIFO manner, we fill in the numbers into the final array as so. 9, then we take 13, 23, 54, and 75. Now that we've completed the tens digit, we see that d is equal to 2 and we have no further significant digits, and we have reached our most significant digit. So this means that this final result that we got from this iteration is the final sorted result from Radix sort. So now we have successfully sorted these 5 numbers using the Radix sort algorithm.